A collaborative editor is a form of collaborative software application that allows several people to edit a computer file using different computers, a practice called collaborative editing. There are two types of collaborative editing, real-time and non-real-time. In real-time collaborative editing, users can edit the same file simultaneously, whereas in non-real-time collaborative editing, the users do not edit the same file at the same time. Collaborative real-time editors generally permit both the above modes of editing in any given instance. History of key products. The first instance of a collaborative real-time editor was demonstrated by Douglas Engelbart in 1968, in the mother of all demos. Widely available implementations of the concept took decades to appear. Instant Update was released for Mac OS in 1991 from ON Technology. Later, a version for Microsoft Windows was released as well, allowing real-time collaboration across these two operating systems. Instant Update relied on a workgroup server to coordinate documents updated in real time on multiple clients. The Web 2.0 phenomenon has caused an explosion of interest in browser-based document editing tools. In particular, a product called Writely saw explosive user growth and was bought by Google in March 2006. It provided simultaneous edits on the entirety of a document, though changes from other users were only reflected after the client program polling the server. Another early web-based solution was JotSpot Live, in which line-by-line simultaneous editing was available in near real time. However, after Google's purchase of parent company JotSpot in November 2006, the site was closed. Google Sites was launched in February 2007 as a refactoring of JotSpot, but it lacks the multi-user real-time abilities of JotLive. The SintraEdit and MobWrite projects are two, more recent, open-source attempts to fill the in-gap real-time browser-based collaborative editing, though still unable to achieve true real-time performance, especially on a large-scale architecture. In 2009, Google started beta testing Google Wave, a real-time collaboration environment which Google hoped would eventually displace email and instant messaging. Etherpad was acquired by Google, which allocated the Etherpad team to work within the Wave project. However, Google announced in August 2010 on its blog that it had decided to stop developing Wave as a standalone project, due to insufficient user adoption. After Google released the abandoned Etherpad source code as open source in December 2009, the community took over its development and produced a complete rewrite named Etherpad Lite, which is written in JavaScript entirely and built on top of Node.js. Technical challenges. The complexity of real-time collaborative editing solutions stems from communication latency. In theory, if communication were instantaneous, then creating a real-time collaborative editor would be no more difficult than creating a single-user editor, because a document could be edited using an algorithm similar to the following: request an edit document token from the server, wait until the server says it's our turn to edit the document, tell the server how to edit the document, release the edit document token. However, the speed of communication is limited by network latency. This creates a fundamental dilemma. Users need their own edits incorporated into the document instantly, but if they are incorporated instantly, then because of communication latency, their edits must necessarily be inserted into different versions of the document. An example illustrates this problem. Suppose Bob and Alice start with a document containing the word Mary. Bob deletes M, then inserts H, to change the word into Harry. Alice, before she receives either edit from Bob, deletes R, then deletes A, to change it into My. Both Bob and Alice will then receive edits that were applied to versions of the document that never existed on their own machines. Thus, the challenge of real-time collaborative editing is to figure out exactly how to apply edits from remote users, which were originally created in versions of the document that never existed locally, and which may conflict with the user's own local edits. The most sophisticated solutions solve this problem in a way that does not require a server, does not use locking, and supports any number of users. Una and SubEthaEdit are examples of two programs that take this approach. While these sophisticated approaches enable the best user experience, a basic collaborative editor can also be created in a client-to-server model. In a client-to-server scenario, one of the editor instances is assigned the role of collaboration server when the document is opened. This server ensures that other editors are kept in sync by determining network latency and acting as a time synchronization server. The server receives time-stamped notifications of changes made to the document by other users. It determines how those changes should affect its local copy, and broadcasts its changes to the collaboration pool. In some models, the changes are not reflected on a client until an official response is returned from the server, even if those changes were made locally. This approach, while significantly less powerful, allows for basic collaboration at a relatively low cost. This makes it preferable in situations where processing resources are limited, such as on Apple's iPhone platform. NetSketch is an example of a program that uses this model. In the past, Microsoft and IBM have worked to add collaboration facilities to their existing architectures. Although marketed as real-time collaboration, these workspace approaches require either document locking, or reconciliation of conflicting changes, which is generally found by users to be unsatisfactory. See also, Collaborative Document Review, List of collaborative software, Distributed computing, Operational transformation, Conflict-free replicated data type, Distributed revision control, Paint chat, Oekaki, Real-time text. References